Hi guys, here we are, Math Week 1, Part 2, Pythagorean Theorem. Now we've been doing this all year long, so hopefully when you take a look at it, you think, oh, I know how to do this. This is just extending what I already know, okay? So Pythagorean Theorem, can we show that the Pythagorean Theorem really works for any right triangle? Right triangle has 90 degrees in the corner, okay? So step 1, recall that the area of a square can be found by the formula A equals S squared, where S is the side. Okay, so then what is the area of square B? And square B is over here. It has B1, B2, and B3 all put together. Step 2 says, cut out the triangles and square A and rectangles B1, B2, and B3. Place square A and rectangles B1, B2, and B3 on the side of C of the triangle to form a perfect square if possible. So if possible, your new square has the area C squared. Okay, so does that work? Let's go ahead and find out. Okay. Erase. And notes. Hello. There we go. All right. Now we've already done these notes. This should be in your folder, but let's take a look. I'm going to run through it very quickly. In a right triangle, the legs are the two sides that form the right angle, which is the 90-degree angle, and the hypotenuse is the side that is opposite that. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. Of course, that is A squared plus B squared equals C squared. Okay, so over here in our example, to find the missing length, we have A squared plus B squared equals C squared. So it ends up being 9 plus 16, which is 25. Easy, perfect square. Square root of 25 is 5. So 5 equals C. Still works for this example here where we are looking for the unknown, which is A. We know what C is and we know what B is. So A squared plus B squared equals C squared. We're going to plug in those values even though they're a decimal. And I know my little thumbnail covers it over for me, but right down here, let's see, it ends up being, I'll do the bottom part for here. So we have A squared plus B squared equals C squared. A squared, we're going to plug in 2.1 squared and 2.9 squared, which gives us 4.41 and 8.41. Right here, we're adding negative 4.41 to each side. So I'll continue it over here so you can see it. A squared equals, and using my phone is my calculator. So we have 8.41 minus 4.41. Well, what do you know? Equals 4. Find the square root of both of those. So we know that the length of side A is 2. Okay? Easy peasy. All right, so this next page here, this is your reference page that is included. This is from your red resource book that we would normally use in class. So if you need some extra help or you're not sure, come back and reference this page. Okay, and these are the new things that have been added for this distance learning, which is actually pretty rad, but this is a step-by-step guide. Okay, so it says, find the length of a side of a right triangle. Okay, my little. All right. So step 1, know that the hypotenuse is opposite the right angle and is always the longest side, and that's shown by letter C. Okay, longest side shown by letter C. So over here, here's our right angle. Over here, this is our hypotenuse. Okay, you can switch out A and B. That's okay. But C is always the side that is opposite the right angle. Step 2, recall the Pythagorean theorem. A squared plus B squared equals C squared. Step 3, substitute the numbers for the letters and solve the equations for the unknown. Okay, so you'll see we'll plug it in right there. So Here's an example here. Over to step 4, take the square root. This is shown by this radical sign of both sides of the equation. Square root of a quantity is the number or variable that when multiplied by itself equals that quantity. Okay, so it's just reminding you these are both perfect squares. Okay, so let's get on to our work. All right, you guys feeling good? This is something you remember? Hope so. Okay, so here we have our example, find the missing side. So when I'm looking at this, of course, I know that the theorem is a squared plus b squared equals c squared. Over here, I can see that I am looking for a. That means that 6 is going to be my b and 8 is my c. So let's plug those in. So we have a squared plus b squared equals c squared. A is my unknown, b is 6, and c is 8. A squared plus 36 equals 64. I'm going to add the opposite, which is subtracting 36 from each side. Gives me a squared equals, let's see here, 64, take away 36. Should be able to do in my head, but we'll just use the calculator. 28. Well, 28 is not a perfect square. Okay, so we're going to use our factor tree like what we did with the square roots. So here we have 28. You can go 1 times 28, 2 times 14, not 3, 4, there we go, 4 times 7, and that's it. So I see 4 is a perfect square, so let's work that out. A squared, or I guess square root, I want to erase that, sorry. So I'm going to do square root right here. So now a is going to be the square root of 4 times the square root of 7. So then a equals square root of 4 is 2 times the square root of 7. And I messed up again. Look at, don't need that squared because we already did square root. So there is our answer. A equals 2 times the square root of 7. I check over here. It's correct. Woo! Okay, there's the example. There we go. So for all of these problems, you're simply going to use the equation a squared plus b squared equals c squared. Okay? All right, let's get going. All right, and here's where it's funny because as I'm writing on my Chromebook, I get real close to the camera, but that's okay. All right, so number 1. We are always using, in fact, I'm just going to write it here and keep it. Or not, I guess if I delete my whole page, but we'll see what my fancy is. All right, so we have 6 and 8. 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. Add those together. 6 and 4 is 10. So that makes 40 plus 60 is 100 equals c squared. Square root, it's a perfect square root, which means 10 equals c. And I know that this gave me a label. It's going to be meters. C equals 10 meters. I see it right there. Yeah, I am just going to delete my whole page. That's okay. Number 2. Okay, so look at, they're switching which side my right angle's on. No big deal. It's still the same equation. A squared plus b squared equals c squared. Okay, so 16 feet squared plus 30 feet squared equals c squared. Okay, I do not have 16 squared memorized. So 16 times 16 is 256 plus 900 squared, same as 3 squared plus a couple zeros, equals c squared. I can add those easily, gives me 1,156. Oh, just writing a bunch of extra squares on here. All right, equals c squared. I need to find the square root of each of those. So remember, you turn your iPhone sideways, and it is going to be this square root. So it has that little 2. I don't know, I can't even tell where I'm pointing. So it's square root. The one with the 3 is a cube root. Okay, so I'm going to say 1,156 square root is 34. 34, remember our label is feet, equals C. And there it is on our answer key. Going well. Number 3. That's a 3. Oh, it's an ugly 3. There we go. Kinda. Still ugly. A squared plus B squared equals C squared. Okay. 9 centimeters plus A. Oh, look at, I reversed them. Is it okay? Yeah, it's they both are addition, so I can put them in any order. Equals 15 squared. 9 squared is 81 plus A squared. And I think 15 squared is 225. Let's check my memory. Yes, 225. Okay, now I want to solve for A, so I need to subtract 81 from each side or add the opposite. So that leaves me with A squared equals 225 minus 81 is 144. And I know the square root of 144 is 12. So A equals 12, and my label is centimeters. 12 centimeters. And there it is at the top. Okay, there we are. 4 for 4. We're on a roll. 2 more. Okay, number 5. Oh, still an eraser. 5. A squared plus B squared equals C squared. Okay, so, oh my goodness, fractions. I hate fractions, but we can do it, okay? So we have 4/5 squared plus 3/5 squared equals C squared. Okay, so now looking at these fractions, do you guys see a problem? So right now it looks like 4 squared over 5. Okay, so I'm going to put my parentheses here because we need to square both the numerator and the denominator. Okay, so then it's kind of easy because I can deal with those numbers. Okay, so 4 squared is 16 over 5 squared is 25 plus 3 squared is 9, 5 squared is 25, equals C squared. Well, thank goodness they have the same denominator because I can add them easily. Look at this. 16 plus 9 is 25 over 25, which is the same as 1 equals C squared. And I kind of skipped the step right there because I'm out of room. Were these fractions huge? So square root of C squared, square root of 1 equals C. And Oh, good thing there's no label because I didn't leave room. See, so it looked crazy, but we did it. Ah. All right, good. Last one, number 6. Okay, so we have a squared. A is our unknown. 4 inches squared equals 10 inches squared. Solving for A, 16 equals 100. Subtract 16 from each side. So A squared, what is that? 84. Oh, well, that is not a perfect square. So then I need to do my factor tree. 84. Oops, what is square root sign, I guess. I don't know. All right, here's my tree. 1 times 84. 2 times 42. 3. Does 3 go in there? 8, 9, 10, 11, 12. Yeah, it should. So 3 goes into 8 twice, which then leaves us with 24. Ooh, 28. Okay, 4 goes in there 21 times. And then not 5, 6 out. So look at 4 is going to be our largest perfect square. So we are going to say A equals square root of 4 times 21. Okay, we can separate those out. I'm going to do it right here. Square root of 4 times square root of 21. Square root of 4 is 2. So we have 2 times the square root of 21. Is that our last answer? Yes. All right, here we go. First assignment, easy peasy, right? Lemon squeezy. Let's erase that. Whew. And we're just going to keep plugging along. So you can either pause here or keep going. So turn over your piece of binder paper or get a fresh one. Doesn't really matter. And we're going to keep seeing what we understand about Pythagorean theorem. Okay, so this assignment actually switches it up and it's giving you all 3 numbers and asking for you to plug them into the equation to see if it is a right triangle. Okay, now if it's not a right triangle, it's still a triangle because it has 3 sides. It's just not a right triangle because it doesn't have that 90-degree angle in one corner. Okay, so this says determine if the side lengths given could represent a right triangle or not. And so it says recall right here. Recall that in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse of the or the longest side. Okay. All right. So our first one gives us 7, 11, and 15. We know that 15 is going to be our hypotenuse, or c, because it's the longest. So with our equation, a squared plus b squared equals c squared, plug those in. 7 squared is 49. 11 squared is 121. 15 squared is 225. If you add 49 and 121, it equals 170, which is not the same as 225. So right here, remember the 3 dots? Therefore, it is not a right triangle. Okay? All right. Here we go. Number 2. Let's see. I can't read what that says. Answer. Let's see. I've got mine right here. Answers. 2 are yes. Oh, and 2 are no. Oh, I guess I can read that there. Looky there. 2 are yes, 2 are no. How equal opportunity, right? Okay, so let's look at number 2. We are putting it into a squared plus b squared equals c squared. 12 squared plus 16 squared. Does it equal, 20 squared? I know that is 144. I know this is 400. 16 squared, I don't remember. 16 times 16, 256. We've had that a couple times. Should remember it. Okay, so then we go 256 plus 140. I think I multiplied. 144 plus 256 equals 400. 400 equals 400. Therefore, right triangle. Okay, number 2 is a yes. Number 3. Where's my pen? There we go. 3. All right. Fun fact. Did you notice that my pen color is the same as my pen color? Must be delirious, but fascinating. All right. Number 3. 8 squared plus 12 squared equals 15 squared. All right, I know all of these. So 64 plus 144, does it equal 225? Let's add them. I can already look and see because my ones place, 4 plus 4 is 8. That gives me 10, carry my 1, and 208, does not equal 225. Therefore, there we go. Therefore, not. Or are we going to say no? 2 yeses, 2 no's. This one's going to be a no. Can't win them all, right? All right, number 4. A squared plus b squared equals c squared. Our contestants today are 9 squared plus 14 squared equals 17 squared. I know 9 squared is 81. 14 squared is 196. And I know some of you are just watching this video because you don't want to get out your calculator and you're just waiting for me to do it. It's all right. 289. Okay. All right, so now let's add them up. 81 plus 196. 277 does not equal 289. Therefore, another no. Race. All right. Number 5. Okay, so a squared plus b squared equals c squared. 10 squared is 100 plus 24 squared, 576. And 26 times 26, 676. I did think that, I know it's rare that I make a mistake. I mean, really, really rare. But you might want to check my work. I don't know. All right, and I can look at this easily. 100 plus 576. I know I got this one right. Equals 676. Therefore, winner, Pythagorean dinner. That would be a yes. Right? Okay. That's it, 1 through 5. All right, so this right here says, if a right triangle has a hypotenuse as given below, what integer values could the 2 legs have? right when we were on a roll. Okay, so C says if C equals 10, then A squared plus B squared equals C squared. So A squared plus B squared is going to equal 10 squared. It says use the process of elimination to guess and check. I know so many of you are irritated because you are not guessers and checkers. You are simply, let's just know the answer, right? And that's okay. That's how you are. But it's putting in practical life things that you need to guess and check. It's okay if you get it wrong. Just guess and check again. Okay, so fortunately, this one does it for us, right? Okay, so guess and check. Would 5 squared, oh, that just covers the whole thing. Would 5 squared plus 7 squared equal 10 squared? So that gives us 25 plus 49 equals 100. Well, 74 does not equal 100. So the two sides are not 5 and 7. Okay, so let's just make an adjustment. Let's go one higher up. 6 squared plus 8 squared. So here they are here. 36 plus 64. Yes, that does equal 100. So there we have 100 equals 100. Okay, so we have two that we need to guess and check to figure out. I have not pre-done these. So either I will have a lucky guess or we'll have to guess and check a couple times. Okay. And no groaning and rolling your eyes if I don't make the right guess at first. You just keep writing. You don't erase it. That's your work, okay? All right, number 7. C equals 15. So we need to just make a guess for our A and our O and our B. And it's going to equal 15 squared. Do you remember what 15 squared is? We've seen it a couple times. 225. Okay, so let's make some guesses. I already know from our last problem that 6 and 8 is going to be 100, not 225. So I need it to be much bigger than that. Okay, so let's do, I don't know, 9. Want to go bigger? Let's do 12. I like 12. 12 is 144 and 13. Give it a go. 12 squared plus 13 squared. Does it equal 225? 144 plus 169. What does it equal? I don't think it's going to work because 9 and 4 does not end in a 5. 144 plus 169, 313. Okay, so I can look at this. Okay, so 313 is too big by actually a lot. But let's see here, 44, I know that it needs to, if I have something that ends in a 1, so instead of 13, let's try 9. Okay, so you can just rewrite this. I'm going to painfully erase these. And not too bad. And I think let's try 9 because 9 squared is 81. Okay, so 144. Oh, and I meant to write. It's really rolling your eyes. It's fine, just erase it. 9, there we go. 144 plus 81, does it equal 225? 144 plus 81, it does. Woo! All right, so 225 does equal 225. So that means for 7, do you hear me say fur? So for 7, our 2 leg lengths are 12 and 9. Okay, not too bad. All right, now erase. All right, number 8, last one. How come it didn't all erase? Oh, there we go. All right, number 8. We have C equals 5. It would be an 8. A squared plus B squared equals 5 squared, 25. Now, there's just some things that I remember, and maybe you guys do too, because this was on our classwork and on like it's the second side of our math homework multiple times, many. Okay, so we need to figure out what A is and what B is to equal 25. Okay, so there's our 5. And you guys, I remember it being 3 and 4, right? That's our right angle. You guys remember? Let's give it a shot. 3 squared plus 4 squared equals 25. 9 plus 16. Look at that. 25 equals 25. Okay, so hopefully you just start seeing these patterns, because that's what math is. Our two sides are 3 and 4. Woo, I'm so excited. So that's the end of week 1, part 2, Pythagorean theorem. There is a challenge question that I'm not going to put on this video because it is your challenge. Oh, there he goes. It's your challenge, and it is optional, and I hope that you do challenge yourself and see if you can get it done. Okay, so I think what we'll do is maybe I'll briefly go over that when we do conferences. Okay, so I hope you're doing well as you embark on this distance learning and continue every day. Remember who you are, remember what you stand for, and as always, lead by example. Miss you guys. See you soon. Bye-bye. There.